In this discussion video, we will do some special trig limit practice. So let's first recall our two special trig limits. The limit as theta goes to 0 of sine of theta over theta equals 1, and the limit as theta goes to 0 of cosine of theta minus 1 over theta equals 0. So let's get into some practice problems. So I want to look at, from worksheet 6, problem number 8, and have you try parts A, C, D, and E for about 9 minutes. If you get done with these in 9 minutes, then I want you to also try B and F. And there's actually a couple more parts to the problem. So try those if you get done in the 9 minutes. But pause the video now in 4, 3, 2, 1, pause it, and try these 4 for about 9 minutes. Alrighty, so hopefully you did that. Hopefully you paused it for about 9 minutes to try these. So let's talk about part A first. So first, I just want to comment about this. If I were to just start it off by plugging in, I would get sine of 0 on the top and 0 on the bottom. And sine of 0 is 0. So I get 0 over 0, which is an indeterminate form. So I need to simplify. Okay, so I'm going to try to get this to look more like our special limits. So that's going to be our strategy. We're going to make this look like our special limits. Okay, so we will have the limit as theta goes to 0. And I have the sine of 4 theta on top, and I have this theta on the bottom. So to be able to use, because this looks like my first special trig limit, to be able to use that, I need the same angle in the sine that I have on the bottom. Okay, so I have this 4 theta on the top. It'd be really nice if I had 4 theta on the bottom. So I'm going to multiply by 4 on the bottom. But to be able to do that, I also have to multiply by 4 on the top. Because in general, if I have a fraction, it's totally fine if I multiply the top and the bottom by the same number, because then it's like I multiply by 4 over 4, and that's just 1. And multiplying by 1 doesn't change what I have. All right, so now this 4 that I have is just a constant. I can pull that to the front of the limit. So this will equal, that 4 will come to the front of the limit and multiply the limit as theta goes to 0 of sine of 4 theta over 4 theta. But now this limit is as theta is going to 0, and my angle, this 4 theta, is the same inside the sine and on the bottom, and that angle is also going to be going to 0, which means this limit is my special limit, is actually just 1. So I get 4 times 1, which is 4, and that's my answer. So I want to talk about the technical reason for why I'm allowed to just say that this is the special limit. So the technical reason. All right, so the technical reason is we can make this look really like our special limit if we do a substitution. If I let y be equal to that angle 4 theta, and then I'm going to have to be able to rewrite this limit. Right now it says theta goes to 0. I'm going to have to be able to rewrite that in terms of y. So as theta goes to 0, y is going to be going to 0. So we get our limit, which is the limit as theta goes to 0 of sine of 4 theta over 4 theta. That limit will be equal to the limit as y goes to 0, because as theta goes to 0, we got y goes to 0, of sine of y over y. And now that's exactly our special limit. That is equal to 1. All right, so I'm going to put a little bubble around this. We don't need to write out this technical reason every single time. In general, if we have a limit and theta is going to 0, and our angle that's on the top and on the bottom is the same, and that angle is also going to 0, we can just go ahead and say that that limit is 1. Okay, we'll see an example later where it's not as obvious, and I will need to explicitly show this substitution. All right, so let's look at part C. Up in the difficulty a little bit this time. We got the limit as theta goes to 0 of sine squared of 2 theta over 5 theta. Okay, so we get the limit as theta goes to 0. And now let's split this up. I got two sine terms on the top. So I'll get sine of 2 theta. Let's put it over something. times the other sine of 2 theta. Let's put that over something. Okay, and then we have this 5 on the bottom and a theta on the bottom. Well, I like having the theta underneath one of these signs, so let's just put the theta under one of these signs. But the 5, I don't really care to have that underneath either of these signs, so let's just make that the denominator of its own fraction. All right, so we have this, and now let's multiply the top and the bottom by the same thing to start making our special limit appear. So for the first fraction, I'd really like to have a 2 on this denominator. So I'm going to multiply the denominator by 2, but to balance that out, I'm going to have to multiply my numerator by 2. Okay, and with the second fraction, I really want to have a 2 theta on the denominator, but to balance that out, I'm going to have to multiply the numerator by 2 theta. All right, and then with this third fraction, well, I don't really need anything there. There's no thetas there. So I should just finish the fraction and make sure I write something on the top, which should be 1. There'd be a 1 on the top of that fraction. All right, so we have this. Now let's split it up into a few different limits. We get the limit as theta goes to 0 of this first part, sine of 2 theta over 2 theta, times the limit as theta goes to 0 of the next fraction, which is sine of 2 theta over 2 theta. And then we'll get times the limit as theta goes to 0 of, let's see, this ends up being 4 theta over 5. So this is our special limit, which is 1. This is our special limit, which is 1. So we get 1 times 1. And with the last limit, we can just plug in theta. We can plug in 0 for theta to get 4/5 times 0. So overall, this is just 0. And that is our answer. Let's do another problem. All right, so we are moving on to part D. All right, so really similar limit here. Let's do the same thing. We get the limit as theta goes to 0. Let's split it up into some pieces. So I'm going to have 2 sine terms on the bottom. So let's do sine of 5 theta, and then times another sine of 5 theta. And let's put the 1 theta that we have on top of one of these fractions. Maybe I'll put it on the first one. And then I don't want to put the sine of 2 theta at the top of either of these fractions. So let's make that the top of its own fraction. And now let's use our same multiply the top and the bottom by the same thing trick. For the first fraction, it would be really nice to have a 5 up here so that the angle on top matches the angle on the bottom. But if I put a 5 on the top, I got to put a 5 on the bottom. So let's put that here at the end. For the next fraction, I'd like to have a 5 theta on the top. So I balance that by putting a 5 theta on the bottom. And then for the third fraction, I'd like to have a 2 theta on the bottom. So I'm going to balance that by putting a 2 theta on the top. All right, and now let's split up these limits. We get the limit as theta goes to 0, 5 theta over sine of 5 theta, times the limit as theta goes to 0 of 5 theta over sine of 5 theta. I need to split it up like this so I can say definitively that these individual pieces are 1. Okay, so the limit as theta goes to 0 of sine of 2 theta over 2 theta. And then finally times the limit as theta goes to 0 of that last term of, 2 theta over 25 theta. Okay, so this third limit is our special limit. It's going to be equal to 1. The first two are the reciprocal of our special limit. So I want to do a quick note. And we talked about this reciprocal thing in lecture as well, but if we have the limit as theta goes to 0 of theta over sine of theta, so the reciprocal. So this is the reciprocal of our special limit. The limit as theta goes to 0 of sine of theta, over theta. So it's going to be equal to the reciprocal of our limit. It's going to be equal to 1 over the limit of this one, which is 1. And 1 over 1 is just 1. Okay, so that's really nice. Okay, so that's going to make this limit be equal to 1, and this limit also be equal to 1. With that last limit, the thetas are going to cancel. And after we cancel them, we will end up with, let's see, 1 times 1 times 1 times 2 over 25, which is just 2 over 25, and that is our answer. All right, let's move on to part E. So for E, this one looks different. I have a tangent on top. So maybe I try plugging in first, and I get tangent of 0 over 0. But tangent of 0 is 0. So we get 0 over 0, which is indeterminate, so I gotta simplify. All right, so maybe let's try rewriting tangent. I get the limit as theta goes to 0. Let's rewrite that tangent as sine of theta over cosine of theta. And that whole thing is being divided by theta. All right, so this is the limit as theta goes to 0. And when I divide by theta, I can write that as a fraction. That's the same thing as theta over 1. So we get sine of theta over cosine of theta. And dividing by a fraction is the same thing as multiplying by the reciprocal. So we will multiply by 1 over theta. All right, and now let's put the pieces that we like together. So we have the limit as theta goes to 0. Let's do sine of theta over theta together, because that's our special limit. And then times the limit of the other stuff. 1 over cosine of theta. All right, so we said this is our special limit. That's going to be 1. With the next limit, let's just plug in. So we are getting 1 times 1 over cosine of 0. So this is just going to be 1 over cosine of 0 is 1. 1 over 1 is 1. And that's our answer. All right, let's move on to part F. Okay. So this problem, I didn't ask you to try at the start. Unless you got done with the other 4 questions when I gave you the chance to pause it, maybe then you started this question. But let's talk about this one together a little bit first, and then I'll give you a hint and let you think about this one, because this one's a little bit different than the ones that we've done before. So first, let's just kind of examine what happens if we plug in. If you plug in infinity, that's a key difference. Theta is not going to 0 anymore. It's going to infinity. We are going to get infinity times sine of, well, 1 over infinity is getting close to 0. So this is infinity times 0. And remember, this is an indeterminate form. And the reason why it's an indeterminate form is when we write this, infinity times 0, the infinity means we have a huge number. It just means it's getting really, really big. And when we write 0, it doesn't mean it's actually 0. It means it's getting close to 0. Maybe I should say it's a number that is close to 0. And that's because when we take a limit, we're technically not plugging in this number, even though that's how we evaluate it algebraically. We're just thinking about, well, what happens is theta gets really, really, really big. And as theta gets really, really big, this 1 over theta is getting really, really close to 0. It's not exactly 0. So that's why sine of 0 is just close to 0. Okay, and when you multiply a huge number by a number that's close to 0, they kind of have a tug of war with each other. The huge number is like, oh, you should be big. When I multiply you, because I'm so big, you should be big. But the number that's close to 0 is like, wait, I'm really close to 0. When I multiply you, I'm going to make you close to 0. So because they have that tug of war, it's kind of a question of, well, which one's going to dominate? Is the huge number dominating, or is the number close to 0 dominating? It depends on what's happening more quickly. Is the huge number growing more quickly, or is the thing that's getting close to 0 getting smaller more quickly? And that's what makes infinity times 0 in an indeterminate form. All right. So this is where I'm going to give you a hint and let you think about this. Right now, this does not look like our special form. So my hint is, can you get it in the form where you have sine of stuff over some stuff first, and then substitute? We're going to need a substitution to be able to turn it into a limit we can handle, because in our special limit theta, our angle is going to 0. Here it's going to infinity. So this is where I want you to pause it for 3 minutes to try this on your own. This is a step up in difficulty. So it's a good check to see, how can you handle a new problem? 4, 3, 2, 1, pause it and try this one for 3 minutes. Don't worry, even if you're stuck for the majority of that time, or even all of that 3 minutes. This one's a little bit more challenging. Alrighty, so hopefully you paused it and tried it for 3 minutes. Let's discuss it together. So we have this limit as theta is going to infinity. So I'm going to keep the sign of 1 over theta where it is, but I can bring this other theta to the denominator, and when I bring it to the denominator, it will get reciprocaled. All right, because that's the same thing as what I started with, because if I divide by 1 over theta, that's the same thing as multiplying by the reciprocal, multiplying by theta, and that would give me what I started with. It's kind of like multiplying by the reciprocal in reverse. Okay, so this is a legal step. And then the hint says, well, substitute. So I am going to let y be this stuff. I see the same thing in more than one spot. I'm going to let y be the 1 over theta. Okay, and as theta goes to infinity, I'm going to rewrite my whole limit in terms of y. So I need to know, well, what is y going to? So as theta goes to infinity, y is going to 1 over infinity, which is 0. Y goes to 0. Okay, so if I substitute in, we end up with the limit as y goes to 0 of sine of y over y, and I've turned it into my special limit, and that's 1. Okay, nice. So let's do one more practice problem. This is part I from that same worksheet question. I want to give you 3 minutes to try this first. So pause it in 4, 3, 2, 1. Pause it and try this for 3 minutes. Alrighty, so hopefully you did that. Hopefully you paused it and tried it for 3 minutes. So with this practice problem, I can see something that sort of resembles our cosine special limit, but there's something that we got to be careful about. Careful. Our special limit is the limit as theta goes to 0 of cosine of theta minus 1 over theta. So the cosine stuff is on the top, and this limit equals 0. And what we have sort of looks like the reciprocal of that, and the signs are sort of switched. So to be able to use this limit, I would have to be able to reciprocal this. But we can't reciprocal 0. So because of that, I can't just use this special limit. So that's a bummer. It would be nice if we could have used that. So I'm going to rewrite what I have. Limit of theta goes to 0 of theta times sine theta over 1 minus cosine theta. And let's instead see if we can remember our strategy for how we did this limit in our lecture videos in the first place. There was something that we did to this fraction to simplify it. And that was we multiplied it by something like the conjugate. I multiplied it by 1 plus cosine theta, and then over 1 plus cosine theta. So if we do that here, we'll get the limit as theta goes to 0. On the top, I'll have theta sine theta times 1 plus cosine theta. On the bottom, I'll have 1 minus, it's 1 squared, which is 1, minus cosine squared theta. Okay, I'm seeing a trig identity. So this is the limit as theta goes to 0 of theta sine theta times 1 plus cosine theta. And then over the 1 minus cosine squared on the bottom, well, that is sine squared. That is sine squared theta. It's come from a trig identity. Okay, so I can do some nice cancellation. One of the signs on top can cancel one of the signs on bottom. So I'm left with sine theta on the bottom. And now I do see a special limit appearing. So let's split this up into the limit as theta goes to 0 of theta over sine theta. Right, this is the reciprocal of my special limit. And then times the limit as theta goes to 0 of 1 plus cosine theta. All right, because I know this is going to be 1. So we get 1 times, and with that second limit, let's just try plugging in. We get 1 plus cosine of 0, which is 1 times, this is 1 plus cosine of 0 is 1. 1 plus 1 is 2. And 1 times 2 is 2. And that is our answer. So the moral there is, if I see one of these special limit questions and it involves this like 1 minus cosine term or a cosine minus 1 term, remember our strategy that helped simplify that was multiplying by this conjugate.